Well, we'll discuss it. Okay. So this is the equation or the function. The function is y equals to x minus 4 times x plus 2. That's the numerator, p of x, and the denominator is x plus 2 times x minus 1. Let's first look at the non-permissible value. So what are the non-permissible value? Okay, right. So non-permissible value are x is equals to minus 2, and the other one is x equals to 1. Okay, that's good. Now this part here, x plus 2, has a common factor with the numerator and denominator. So that means at this x minus 2, there's going to be a hole here. Okay, so if we have a common factor, then there is a hole. If there's no common factor, then this is where going to be a vertical asymptote. Okay, so the hole is there because it's a common factor. So the question is, what is the equation of the vertical asymptote? Vertical asymptote would be x equals to 1. Now, you look at this one, and here, this is the picture of it. This is the vertical asymptote. X equals to positive 1. Okay? If this wasn't here, we could still figure it out. Yes? What's the equation of the horizontal asymptote? Okay, how do we figure out the horizontal asymptote again? Okay, what's the degree of p of x is 2, right? Because x times x will give us x squared. And what's the degree of the denominator? It's also 2. So the degree of p of x is equals to the degree of q of x. So that means the horizontal asymptote would be the leading coefficient of the p of x divided by the leading coefficient of the denominator. So what would be the leading coefficient of the numerator? It's going to be 1. It's going to be 1 over, what is the leading coefficient of the denominator? It's also 1. So therefore, the horizontal asymptote is 1. Y equals to 1. What's that? Yeah. Oh, right here, yeah. Yeah, because we're looking at because this eventually will cancel, right? Because, like, what's the leading even if we expanded this, what would be the leading coefficient of the polynomial x? It's gonna be 1. And what's the leading coefficient of the polynomial q? 1. So that's why we said 1 divided by 1, which is 1. Is that okay? Did I answer your question? Yeah, okay. What's the domain? Yeah. So the domain are actually broken up. There are actually 2 values that's not allowed. There are 2 values that are not allowed, right? Non-permissible value. So the domain would be from negative infinity up to negative 2, union from negative 2 to positive 1, union 1 to infinity. Okay. So you have negative infinity to positive 2. That's actually this part over here of this graph. And negative 2. Negative 2, because there's a hole at negative 2. So the domain, that part is from here, negative infinity, up to this part. And then the other part would be from negative 2 to 1, right? From here to here. Okay? And then the other part of the x, the domain, is from 1 to infinity. Okay, so this chunk up to that point, this chunk up to that point, and then this chunk up to that point, or infinity. Okay, so the domain are any x values except negative 2 and positive 1. So those are the non-permissible values. Okay, so the domain. Yeah, so we can certainly write that down. We can say set notation, x is an element of real numbers, so that if we state that means all numbers are possible, but an exception of x cannot equal to negative 2 and 1. Yeah, so that's another possibility of writing it. So you can have anything, any real number, with exception of these two values. Because this one's going to give us a whole, and then this one's going to give us the asymptote. Okay, good. Okay, now let's take a look. What about the range? What are the possible values for the range?
1 to 2, 2 to infinity, negative infinity to 1.
1, negative. Okay, let's start from the bottom all the way up. So we can say negative infinity up to 1, union 1 to, okay, so from negative, from this part to here, that's that chunk. Now this chunk here, from 1 up to 2. So from 1 up to 2, not including 2, so we're going to put around brackets there. Union 2 to infinity.
You have to go all of the top there? What if you mix those around?
From bottom to top. Just like when we talk about the domain, from left to right, bottom to top.
So if it's in a different form as well?
It's not wrong. You might get a deduction of, yeah.
Will you deduct it?
I will.
You will.
Yeah. What about the range? Okay, what about the range in a different notation? We can say all y values, okay, except x cannot not x, y cannot equal to 1 and 2. Okay, so we can say you can take any values for y with the exception of these two. So either or is perfectly fine. Okay. Coordinate of the whole. Okay, coordinate of the whole. If you look at the picture, what is the coordinate of the whole? Yeah. Negative 2, comma 2. Okay. Well, that's kind of nice because we can see the picture, right? But what if we don't have a picture? How can we figure that out? Okay? Because this part If only this is given, how can we figure that out? Where's the whole? Okay, so where's the whole? How do we do that? Y equals to x minus 4 times x plus 2 over x plus 2 times x minus 1. We said that because there's a common factor, there's a whole there, right? So if we cancel those two, what's left over? Y is equals to x minus 4 over x minus 1. Okay, so we've taken the negative 2, we've taken the negative 2, and we're going to put that over there. Okay, so pretending that x plus 2 is not there, we're going to substitute x equals to 2 into our equation, into our function. What would we get? 2 minus 4 over 2 minus 1. What's that equal to? Y equals to negative 2 over 2 minus 1 is 1. Okay, so we said x equals to 2, and that's going to give us y equals to minus 2. Oh, minus, oh, okay, back up. Minus 2. Okay, this one should be minus 2. So if this is a minus 2, it's going to give us minus 6 divided by minus 3, so it's minus 2. So it's minus 2. Minus, positive, oh my gosh. Positive 2. So negative 2, positive 2. So looking at the non-permissible value, the ones that you canceled out, you put in there, and then you work it out, and it's going to give us that one. Okay? Is that okay? We're going to try one more. Okay, let's try this one. The thing about this one here is that it's not factorable. It's not factorable. Let's see if we can factor this out first. What would be the factored form of this one here? X plus 4, x minus 2, and what's the denominator? X plus 1, x plus 4. Okay. Now, looking at this one here, what's the non-permissible values? Yeah. So looking at this one, the denominator will make it 0 when x equals to negative 1 and negative 4. Okay. So these are the non-permissible values. You notice that x plus 4 is a common factor, both numerator and denominator. So since these two cancel at x plus 4, so that means this one is going to be a whole. And then this one is going to be the vertical asymptote. Okay? Yeah. Okay. So the vertical asymptote would be negative 1 the non-permissible values first, starting with that one. And since x plus 4 cancels, that's a common factor, then there's a hole at that particular point. And then this one here is a vertical asymptote. So far so good. So vertical asymptote would be x equals to negative 1. Yeah? Okay. What about the equation of the horizontal asymptote? The degree of the numerator and the degree of the denominator are equal to each other. So therefore, okay, so if this is true, then the horizontal asymptote will be y equals to a over b. A over b. What would that be? A is the coefficient of the numerator, okay? And then the b is the leading coefficient of the denominator. So y equals to 1. Y equals to 1. And then we can see here, y equals to 1 there. Okay, so far so good? Yes? What's the domain? Yeah, negative infinity up to where that hole is, that's negative 1, union negative 4, and then from negative 4 up to negative 1, and then union from negative 1 to infinity. What's the other possibility? We can say x is an element of real numbers, but x cannot equal to minus 4 and minus 1. Is that okay? What about the range? The range are the minus 4. Minus 4, minus 1. What about the range? From negative infinity up to 1. So negative infinity up to 1. Union. 1 up to 2. 1 up to 2. And then 2 to positive infinity. Okay? Okay. What's the other possibility? Y is an element of real numbers with an exception of y cannot equal to 1 and positive 2. Okay, what's the coordinate of the hole? Okay, so the coordinate of the hole would be this one right here. Minus 4, positive 2. Minus 4, positive 2. How do we do that without the graph? How do we do that without the picture? Okay. Well, we know that there's a hole at negative 4. Okay. So hole at x equals to negative 4. So once those negative 4 cancels out, we're left with x minus 2 over x plus 1. Yes? Right? Because we've canceled this 2 out, we're left with the x minus 2 divided by x plus 1. So we're going to put that x value in here. So the negative 4 minus 2 over negative 4 plus 1. So that's going to give us negative 4 minus 2 minus 6 over minus 3. Negative 6 divided by negative 3 is positive 2. So when x is negative 4, y is positive 2. Yeah? Okay. I don't think we'll finish everything today. I don't think we'll finish everything today. It's really long. It's been too long. Here's what I'm going to ask you to do first, because what we're going to do later on, as you can see here, just to kind of preview what we have, there's going to be no more graphs. There's going to be no more graphs in here, and then without the graph from scratch, we're going to figure out the asymptotes, vertical and horizontal asymptotes, domain and range. If there's a hole, we're trying to figure that out. Okay, so this is what I'm going to ask you to do for you to try. Okay, for you to try. It's going to be on page 104. Page 104, questions 1, 2, and 3. Okay. This one here, we're just going to predict. Okay, so question 1, it says here, predicting whether the graph will have a hole or not. Okay, so what are the non-permissible values? And then number 2, without graphing, can we figure out the vertical asymptotes? And then number 3, what are the horizontal asymptotes? Okay.